Greenland's massive ice sheet is now fracturing and collapsing far faster than historical climate patterns can possibly explain. Since 1990, extreme ice sheet melt has surged sixfold, driven by rising atmospheric temperatures that supercharge localized melting. This rapid acceleration drives global sea level rise and shifts the Arctic into a center for new strategic, economic, and territorial dynamics. This side-by-side map shows the geographic spread of the melt across Greenland. Since 1990, the surface area affected by extreme melting has expanded by 2.8 million square kilometers every decade. Meltwater volume has also surged. Extreme events produced 12.7 gigatons per decade between 1950 and 2023. Since 1990, it jumped to 82.4 gigatons. These events are compressing in time, with 7 of the 10 worst occurring since 2000. Modern meltwater production has no comparable dynamic precedents in the historical record, indicating current conditions are highly unusual and compounding. Northern Greenland has emerged as a primary hotspot, barring the brunt of these intense surface changes. Researchers attribute this intensification to a thermodynamic effect, where rising atmospheric temperatures increase melting beyond what circulation patterns alone explain. Under identical weather patterns, current extreme events produce up to 63% more meltwater than those recorded in the 1950s. Projections indicate that under high-emission scenarios, these meltwater anomalies could triple by the end of the century. This massive volume of meltwater flows directly into the open ocean, creating vast interconnected risks for the entire global environment. The first threat is accelerated global sea level rise. The second involves altered global ocean circulation patterns, driven by the massive influx of fresh water. These changes place coastal infrastructure, human populations, and marine ecosystems in immediate jeopardy. Greenland's physical changes are now central to emerging global security and economic issues. As the ice sheet recedes, the Arctic opens to new territorial claims and economic dynamics that were previously physically impossible. Policymakers must integrate this thermodynamic acceleration into risk management, specifically for sea level modeling and Arctic territorial strategy. Monitoring Greenland's ice sheet is an essential